Hey guys, I'm Chris.
Hey guys, my name's Keanu.
I'm Kyle.
Hi, I'm Ashley, and this year we participated in a national collegiate design competition hosted by Source America, where we designed a kitting workstation for individuals with disabilities. Kitting, which is the assembling of parts into pre-sorted kits, is a process that requires much dexterity as workers need to sort, bag, and seal items. This process is difficult for those with dexterity impairments or motor disabilities, leading to a lower job retention rate. The purpose of our workstation is to make the process more efficient and increase quality assurance so that users with disabilities can increase their job retention rate and kit with ease. When beginning our design process, we started by having various ideation sessions to create initial prototypes and eventually used a morphological matrix to combine and compare different design ideas together, and then a final decision matrix for our final design.
So this is the final design we came up with. This workstation simplifies all complicated motions during the kitting process into simple push-pull movements, as well as consolidating any common processes like the heat sealing and hooking and placing the items into the bag into one simple process. This station works by the user manually placing items into the holes in the top template. Then they push the handle in, which allows the hooks to grab onto the bag, and it is pulled out to keep them open. This handle is then pushed in, which aligns the holes in this top acrylic template and drops the items down into the bags, where they are then heat sealed using the same slider. And then from there, the user can manually rip off each bag and it drops down into this area. Next, the bags are labeled and then placed into this funnel where it drops down into another bag with a similar assembly. During this process, we've attached an additional optional tool for folding some paper instructions, which then the user can place into the same funnel hole. Then it drops down into this weighing scale, which is used as a final test of quality assurance for our product. To repeat the process, the user cranks these ratchet handles, which allows the bags to rotate and the process can repeat.
For our design justification, we created an FEA analysis and a structural prototype. This FEA determined the appropriate thickness of the housing. We determined the thickness of 1/4 of an inch for the housing. This FEA was to test for any displacement within the shaft holding the bags. After applying the force representing the weight of the bag rolls on the shaft, we saw a maximum displacement of 0.02 of an inch. The structural prototype here we made will be a close representative of the overall concept design. However, the structural prototype will only have a single top-down column. Our team built a structural prototype for a fit test and to physically inspect the sizing of key components in our workstation.
Along with the fit test, we built the prototype to also test the different systems of our design. We conducted a sorting test to observe the success rate of the sorting system. We conducted a hooking test to observe the ideal positioning of the bags before hooking them. We conducted a heat sealing test to find out the ideal heat sealing setting for optimum heat sealing. We conducted a tipping test to find the maximum pushing force before the prototype began to slip. We conducted an efficiency test to observe the difference in kitting times when using the workstation versus manually kitting them. And finally, we conducted a comparative dexterity analysis test to observe the kitting times for different types of impairments, such as having one eye or having one arm. After conducting all these tests, we concluded that the prototype did not do as expected because of the lack of efficiency of the workstation versus manually kitting them. However, we must also keep in mind that the prototype does not include our overall design's ability to kit and heat seal 5 different bags in one motion. But with that said, if given more time, we would go back and make design revisions based on the test results, which would likely help us increase the efficiency of packaging workers with dexterity impairments, and that would directly result in a higher job retention rate. A key lesson we learned throughout this whole process was that the testing process will show many flaws within your design, which is completely fine because it's an important step to creating a perfect design. And with that said, we appreciate you taking the time to learn a little bit more about our design, and thanks for listening.